Okay, imagine a famous YouTuber tweets about your AI startup. Your stomach drops thinking it's another Slender tweet, but turns out it's not. He praises it. After that, the tweet goes absolutely viral and suddenly hundreds of people are trying to access your app. So far, you've got 0 MRR and you've been only using free database tier. So the question is, will your database handle the traffic or will it completely blow under pressure? So I set up a fake app called AI SlopFactory. Then I've simulated hundreds of thousands of people accessing the app at the same time. And the results were actually quite shocking. So in this video, you'll learn first, what are some most common mistakes making your database slow? 2, how to very simply fix them and make your database faster. And 3, how you can load test your own database. Okay, so I've generated a fake application called SlopFactory, where users generate projects and then can basically talk with AI. And AI can use tools, there are agent calls, etc. So you can imagine a total normal AI startup. So this is what we want to simulate. Let's imagine you have some little active users, like let's say 5. Suddenly a big creator tweets about your project, goes slowly up, peaks at let's say around 100 users, and then it slowly fades, right? This is what we want to simulate. The results shocked me. The average response time was below 50 milliseconds. Now, this is for 100 active users. And now you can also see other numbers like median, P90s, P95s, and you might be wondering, why are we measuring those and not only averages? But let me quickly explain why. A very quick lesson in statistics now. Put Elon Musk, me, and 6 homeless programmers in one room, and someone might come and say, hey, this is a room full of billionaires. The average net worth in that room is 100 billion. This is exactly why averages are misleading, because it doesn't take the fact that there's one guy with 800 billion and others with basically close to 0. This is why we cannot trust averages on their own. This is how a typical, let's say, API graph might look like. Most requests are okay, but very few are extremely slow. And because of that, the average might look okay, like you might check it and say, hey, this API is pretty fast. But very few extremely slow responses might suggest there's something extremely bad going on with the API. My curiosity has driven me to test how many total users our database can handle, and the direct connection, we were able to achieve close to 900 active users. But what was even more crazy is that once I enabled connection pooling, which I'll explain what it is in a second, I was able to get 10 to 12,000 active users. So 10 to 12x increase comparing to direct connection, which was absolutely insane because this is the most simple fix you can imagine. Short, when you're connecting with a database directly, every time you send a request, you have to first request a connection, then the database have to accept the connection, and only then you can query the data. So on every request, you're basically wasting time on acquiring connection every time. However, with connection pooling, we are keeping an amount of connections at all times. So whenever you query the data, you don't need to establish a connection like here. What you can do is basically just reuse the connection that's already there and query the data much faster. The fix for it is so simple. You actually go to Neon database and you can only click this. So you click the connection pooling. This one, connection pooling, is by far the biggest performance killer, but there's a second closest one, maybe even bigger than connection pooling, to be honest with you. And this is indexes. So I've decided to test the database and disable all indexes and see whether anything changed. And what I noticed was, at first, every response seemed okay. I mean, they were a little slower, but not a lot. But when you look at this one, dashboard stats loaded, it's 10 times slow. Tell you why. When we go into this, problem with this query is that we are fetching conversation with agent runs and tool calls. And basically, if we do not have indexes, we have to search all of the data. When we fetch conversations, we have to compare it against literally every single agent run to see whether the conversation ID matches. This is called a full table scan, and let me explain it more deeply. So when we have this, instead of having some type of a connection between the data, we have to basically check, okay, is this the data that we need? No. Is this one? No. And we continue until we find the data that we need. And you can imagine that, let's say there's a 50 elements, this might be pretty fast, but what happens with 50 million elements in the table? The response time gets absolutely slower. Now, with indexes, we are effectively creating a very tiny chain that connects our data. So every time we fetch the conversation, we already have the message associated with it. That's how you can think of indexes, are sort of those tiny little chains. So you might be thinking, okay, David, then I will create literally all of the indexes possible. And this is exactly what I did, because this is not good either. I've created 122 custom indexes with data that I never use. And honestly, the results weren't that extreme. The user created query was twice as long. So it wasn't that complicated, but the problem gets bigger with more data. You can imagine every time we create those strings, we are creating a small piece of data. And so you can imagine the more strings there are, on every insert, we generate 10, 100, 1000 new pieces of data. And this makes our database bigger. And so this is not good either. So what you want to do is connect the data that you fetch together. So for example, if I'm fetching conversation with messages, I want to create indexes for it. But if I never fetch projects with messages, then it completely doesn't matter, right? It's like, it's not needed. And so only fetch data for those that are called your access patterns, the way you actually fetch the data. So now you might say, okay, David, all of this sounds great, but it's like my app is not SlopFactory. I have something completely different. And honestly, you're totally right. So let me show you how you can completely do it yourself at home. So first, let's download K6 Studio. Then from the point of your app, let's create something called a recording. So record your app, record a typical user journey like you can imagine. As you can see, all of those requests are aggregated here. Once I have the request, I can generate new test, and I can generate the new test from the recording that I've just did. And then I will have the script. And this script is fantastic because you can pass it to either cloud, either codecs, and you can basically play with it how you want. So this is it. This is how you can test your database. And honestly, if in 2026 you're serious about scaling your app, you want to make sure to know where their bottlenecks are. And this is actually the most crucial part, because in this example, I realized the bottleneck was connection pooling, having an increase of 11x at the same time, like with literally changing one URL. Thank you so much for watching, and thank you, and see you again.